This video is going to focus on the details on how streams erode sediment in the headwaters, transport the sediment through the middle, and deposit the sediment at the mouth of a stream. When we're looking at the different erosional agents on our planet, whether it's gravity, wind, streams, or just precipitation, we see that streams are going to be one of the most important. Water is fantastic at moving sediment around. If we look at a single raindrop, it has enough power that by the time it hits the surface, it's typically traveling at about 20 miles per hour. And if it hits a loose pile of dirt, it's capable of moving some of that sediment up to 3 feet away, just from a single raindrop. So we see that water is incredibly powerful, especially if we're looking at an entire stream instead of just a single raindrop. When we're looking at a stream, we're going to see that as the water is flowing through an area, it's actually capable of moving around and lifting around the sediment, whether it's lifting sand or pebbles from the bottom. But it's going to be able to further erode that sediment more easily as that water flows over it. And sometimes when the stream is strong enough, it creates a hydraulic force or pressure that's so strong that it can cut into solid rock. So if we look at the bottom image here, we can see these kind of holes within the rock. And this just happens as water is flowing through and swirling pebbles around along the bottom of the rock. But as streams are moving or transporting the sediment from mountainous regions to the coast, we're going to see that the way that it can transport sediment is going to happen in 3 ways, and it's all going to depend on the size of the sediment. So the smallest sediment is going to be in the dissolved load. This is where the sediment is so small it's going to be able to dissolve directly into the water. So this type of sediment is totally invisible to our eyes because it's dissolved. But we're going to see that most of the sediment that moves through a stream is going to be in the second type, which is our suspended load. These are larger sediments, but they're still very small. They're going to be large enough that we can see them with our naked eye. They're not dissolved, but they're very small clay and silt-sized particles. So if you look at the image on the left where we see this brown looking stream, the reason it's brown is because it has a high suspended load. It has a lot of these small sized particles suspended within the water. And then finally we have our bed load. And this is the sediment that's along the bed or the very bottom of the stream. And it's going to be the largest sediment there. Things like sand, gravel, and boulders. Because the sediment along the bed is so much bigger and heavier, it's only going to move occasionally. And it usually only moves whenever we have floods. We have more water moving more quickly that has enough energy to move these larger particles at the bottom. And we can see that there are different ways that the bed load can actually move these larger particles. Some of them are going to move through siltation, which is just a way of saying that the larger pebbles can bounce from one location to another along the stream bed, or the larger particles can simply slide along the bottom. But when it comes to how much sediment is being transported by the stream, there are 2 important words that we need to know, and these are capacity and competence. Capacity is the total amount of sediment that a stream can carry. We know that there's only a certain amount of things that can dissolve inside of water. There's also only a certain amount of sediment that a stream can hold and still flow. And we see that the capacity increases as we increase the discharge or the amount of water. More water just means it can move more sediment. But competence, on the other hand, is how good the stream is at transporting different sized particles. And here the differences are going to be based on the gradient or the energy of that stream. It takes a lot of energy to move bigger, heavier particles. So we see that Fast moving streams, like in a mountainous area, will have a high competence. Because the water is moving quickly and has a lot of energy, it's going to be capable of moving larger sediment sizes. But once we get out to our coast, the ground is going to be relatively flat, slowing down the stream and lowering its energy. It will no longer have enough energy to move the bigger pieces, it'll just be too heavy, but instead it will only be able to move the smaller particles around. So we'll have a lower competence than that faster moving stream in the mountains. But as our stream starts slowing down, we're going to see that the competence is reduced. That sediment is going to start being deposited, and the river is going to start depositing the larger, heavier sediments first. And this is going to lead to something that's called sorting. As rivers progress downstream, we'll see different sized sediments. In the mountainous regions, we're going to have large boulders, but by the time we make it out to the coast, it's going to be those finer silts and clays. Because as the stream slows down over space, it's going to deposit the largest, heavier sediments first. And over time, it'll just move on to the next largest and deposit them, etc. But all the material that's left behind by a stream is called alluvium.